Okay, so remember in the table of value, you have your x and the y. Okay, and what I really liked about what I went around and saw is a lot of you paid attention in class yesterday. So we have the figure 1, 2, 3, and 4. So you have that 1, 2, 3, and 4. But what impressed me was you guys remembered to start at 0. Okay, so that was very good. You guys were paying attention. So for figure 1 right here, there's 3 circles. Figure 2 right here, there's 5 circles. Figure 3, there was 7. And then figure 4, there were 9 circles. So if I continue the pattern, okay, is by 2, subtract 2, subtract 2, subtract 2. And then here, it will mean that I have 1, right? So the pattern here is by 1. So these are just coordinates, so I can now graph it. So graph the relation. So 0, 1, my first point right here, 1 and 3. Oh, wait. 9 minus 2 is 9 minus 7 is 2. Sorry. Okay, so let me take away that. Let me take away that plus sign so I don't confuse you guys. So yesterday when I was taking this similar question up, this is the part that I got a little confused myself too. So yeah, you're doing 9 minus 7, which gives you positive 2. I know when you're thinking about it, you're thinking going down by 2, but we don't put minus 2. So when we subtract backwards, 7 minus 5 is 2, 5 minus 3 is 2. So we know the difference between them is 2. Okay. And then 2 and 5, 3 and 7, 4 and 9. Okay, now if I did my work correctly, if I did the math correctly, it follows the pattern, I should see a straight line. Okay, if I don't, if any one of the points is off the line, I know I made a mistake. I probably counted it wrong, or I wrote the number wrong, or I plotted the point wrong. Okay. Remember, if the first difference is the same, you should see a straight line. Okay. Write the equation to represent the cost. So as we were saying, the difference right here is by 2. The difference right here, 4 minus 3 is 1. So my slope, I'll write it here. So my slope is 2 over 1, which is the same as just 2. Okay, and my y-intercept, this is why it's important to have this first row right here, because now I can see it's just the 1. So what is the equation of this line? Y equal 2x plus 1. Okay, and then how many O's are there in the 50th figure? So can we do that based on the graph? No, because our graph only goes up to 11, okay, and 9. So can't use the graph this time. It will be really, we can use the table, but it will be really silly to keep going and going and going. So best way is to use the equation. I want to figure out in the 50th figure. Should I sub that in for x or y? Eric? X, right? Because x represents the figure number. So 2 times 50 and then plus 1. So you get 101. 101 O's. Okay. So if you were to grade yourself on this, let's say 1 mark for the table, 1 mark for the equation, 1 mark for getting 101, 1 mark for the graph. Okay. So how many of you got at least 3 out of 4? 4 out of 4. Okay, awesome. Okay, good. Oh, I want to go over one more thing with you. Let's say I'm drawing a distance time graph right here. So flip it over on the back. Da, 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 da. So let's say this distance time graph. Let's say okay, something like this. Okay, and we'll say okay. So 1, 2, 3, 4, 5, 6, and we'll say hours. Right. Okay, and then here we'll say 0. Mm, that's 50 and 80. Okay, and then we'll say this is kilometers. Okay. So remember these distance time graph? We talked about the motion graphs in one of the lessons last week. So, oh, sorry. Let me write down A, B, C, and D. Okay, so each of the segments. So I'm gonna create a table right here. So from A to B, um, okay, this is direction, distance, time, and speed. Okay, so from A to B, B to C, and C to D. Okay, so let's try to complete this table together. Okay, so let's say Claire, you're going on a road trip. Where do you want to go? Quebec. Okay, so Claire is driving. Yes, you have your driver license to Quebec. Okay, what's good in Quebec? Okay. So, since she just got her license, she is not driving very fast, and in fact, she can't even drive on the highway. So it's gonna take you quite a while to get to Quebec. Okay. Uh, so let's say, where are you starting off from? Home. Okay, so she's starting from home, going to Quebec. So from A to B right here, is she driving up the street? Is she driving up a hill? What's happening? How do we describe the direction from A to B? Which is right away from home. Okay, or you can say towards Quebec. Okay, so both you can say. So remember, just because you see this line increasing, it doesn't mean you are going faster. It doesn't mean you're going up a hill. So remember, we never say up or down. Okay, Kevin Chan, let's put that phone away. Okay. Distance. How far did you travel? 50 kilometers. Good. Don't forget units. How long did that take you for that 50 kilometer? 1 hour. Okay. Vincent, what was her speed? How do I calculate speed again? Speed equals, right, distance divided by time. That's the formula. So 50 kilometers divided by 1 hour. What's her speed? 50 kilometers per hour. That's right. Okay. Don't forget, speed is 2 units, kilometers per hour. Okay. And then what happened from B to C? Hi, Amy. What happens from B to C? Okay, Claire, what did you do? Took a break for 2 hours. So, um, direction, no direction, you basically stop. So in that distance time graph, horizontal line means you stop. So while you stop, what distance did you cover? Zero, right. And as you said, you stopped for 2 hours for lunch. Okay. And so your speed, 0 divided by 2, it's 0 kilometers per hour. Okay. And then, Vincent, what happened from C to D? Right. Okay. So she continued towards Quebec. And as Vincent said, or you can say continued away from home. Okay. How do I know she's going away from home and not going back home? Right. So your line keeps going in the same direction. So that's how I know you're not going home. You didn't forget anything. So distance wise, how far did she travel from C to D? Derek? Sorry? Uh, that's 50, that's a 80. Yeah, so 30 kilometers, right. And how long did that take her? Yeah, 3 hours. And then so 30 divided by 3. How fast were you going? Okay, so I think what happened was you probably got a flat tire right here. So you took 2 hours to try to put on a wheel, but it didn't work. So you were driving with three wheels at 10 kilometers per hour. But you were so persistent and like you're so determined to go to Quebec, so you kept going. Okay, so in terms of so taking a look at this motion graph right here, is A to B steeper or C to D steeper? Which line is steeper? This one or this one? Yep. Steeper. Steeper means more vertical. So A to B or C to D? Which one is more steep? A to B. And I can tell because the speed was much bigger. Okay, so the steeper the line, the faster your speed. Right? If I change this question up into instead of like hours and I change it to meters per minute or something like that, I could say Claire was running and then she took a 2 minute break and then she started jogging for the rest of the way. Okay, so when you describe these type of motion graphs, you can also use words if you're not doing the calculation. Okay, you can use words to describe the speed. Okay, but don't forget speed formula is distance divided by time. Okay, you do need to know it for Tuesday. Okay, your test Tuesday. Okay, so really quickly taking up some of the homework questions. Da, 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 da. We are very far into the book now. Right here. Okay, so taking up page 6 really quickly. So these inequality graphs right here are ones where you have to shade. So just like this one right here, if it was y equals x, so if it was y equals x, if it was an equal sign, I know that my slope is 1 and my y-intercept is 0. So when I graph it, it's at 0, 0, and then up 1 over 1, up 1 over 1, up 1 over 1. So this equation y equals x is actually like the standard equation of a line. So this line right, this diagonal line right here is like the basic line. Okay? So, but it's not just y equals x. It's y is greater or equal to x. So what's difference between these two graphically? What do I have to do with the second one? If it's an inequality sign. Kevin Shan, do you know? So if it's an inequality, what do I have to do to the graph? Shade it in, right? Since it's y is greater, greater means above. So I shade in this part. Okay. This one right here, 2b, 2b, looking at the y-intercept and my slope, I can tell that my y-intercept is 0 and my slope rise 2 over 1. So my slope is 2. So my equation is just simply y equals 2x. But again, it's shaded, so I know it's not a line, it's an inequality. If you look carefully, you'll see that it is a dotted line, and so it's greater and not greater or equal to. Okay? So in terms of the inequality, if it's greater or equal to, it's a solid line. If it's just greater, it's a dotted line right here. Okay. So that was page 6. Page 7, just going through these really quickly. So again, like these ones with the title, looking at the title, you can tell what the y-intercept and slope represent. So in this case, in the context of the question, you hear me say that all the time. What does it mean? What does it mean? What does it mean? So the 19,000 is the initial value of the car. So selling value, the price of the car at the beginning. And then the slope in this case is the depreciation rate over the years. Okay, so it goes down by I think 2,000 or 1,000 a year, something like that. Okay, if you do the slope. Number 2, determine the rate of change in the linear relation. So first off, looking at this table right here, what's wrong with this table? What's wrong with this table right here? Hannah, does this look like a nice table of numbers? Oh, sorry, Hannah? No. Why not? Because it's out of order. Out of order, perfect. Okay, so what you want to do is either 1, rearrange it back in order. Okay, so you just need 2 points. Okay, and then subtract backwards to figure out your slope. Or technically, I gave you 1, 2, 3, 4, 5 different coordinates. So I could simply just choose any of those 5 given points and use the formula to calculate the slope. Okay, both way works. Okay. You can use either or. This formula, do you have to memorize it? Yes. Will I ask you this formula on the test? Yes. So, well, I'm not too mean. I'm only asking you to memorize 2 formulas. 1, the slope formula, and 2, the speed formula. So those are the only 2 formulas you need to memorize. Yeah, Miss Ching is so mean. 2 formulas. Okay. Number 3 is just rise over run. So 3 over 36. Number 4, to graph this by using the x and y intercept. To find the x-intercept, what do I do? Let y be 0. And Avian, to find y-intercept, what should I do? Let x be what? Not 1, 0. All right, so to find x-intercept, let y equal 0. To find y-intercept, let x equal 0, and sub it into the equation. Oh, oops. All right, you guys did not see that? Number 5. So Rachel has nickels and dimes. If I were to graph this, are the data continuous or discrete? Okay, so how many of you say continuous? If I graph it, it's a continuous line. How many of you say it's a discrete line? Hey, how many of you say that because you saw my answer? Okay, yes, it is discrete, but why? Who has the reason for me why for this question is discrete? Derek? It doesn't have to do with the limit. You can have a million coins. Eric? Right. So you can't have a dime. So you try to go to the store and break the dime in half and say, here you go, here's a nickel. It doesn't work that way. Okay. And don't try that. Don't try to break a coin. Okay. If I were to graph a discrete graph, what will it look like in the graph? Discrete graph is a dotted, right? Good. Okay. Number 6 right here is the relation linear or non-linear. So remember, we just did the example on that piece of paper. If it's linear, the first difference in the y should all be the same number. So here, 4 minus 0 is 4. 0 minus 4 is negative 4. So that's not the same. So it's non-linear. Okay. And then lastly, right here, the table below represents a linear relation. Determine the missing value. So just like what we were doing again. So I can see the pattern in the x. It's going by 2s. So this would go up to the row 0. And then here I can see the difference is 2.5. So if I go 2 subtract 2.5, I get negative 0.5. And 4.5 plus 2.5 gives me the 7. Okay. What's the key word in this sentence right here? The keyword in the question. Linear. What does the word linear tell you? Okay, and in terms of a table? Same slope, same difference, right? Okay, so what do we call this? Do you guys remember? When you subtract backwards, these values are called first difference. Okay, in grade 10, you're gonna do, oh, sorry. In grade 10, you're gonna do second difference as well. Okay, so a heads up. So when your first difference is the same, it's a line. When the second difference, when you subtract backwards again, second difference is the same, it's quadratic. Okay, so you get a parabola. And then if first and second difference are both not the same, then it's neither. Okay. Just skimming through these ones really quickly. This one, 4 pi r squared. How do I know this is non-linear? Right, there's no math involved in this. I'm just looking at the equation simply. Yep. Yeah, it's not a mx plus b form, and also because there's an exponent. When there's an exponent, you know that this is a degree 2. Okay, remember degree back in like chapter 2 or 3? Yeah, so all linear relations has a degree 1. Anything more than that, it's non-linear. Okay, these ones are pretty straightforward. Oh, writing the equation, number 12. Denny, can you help me with this one? So Josh works for a lawn care company. He makes $15 for the day and then $5 per lawn. Okay, so I'll cross that out so that it's a little easier to see. $15 flat rate and $5 per lawn. Can you write an equation for me? Y equals, it's, so what's, should it be 5x plus 15 or 15x plus 5? Which one should it be? Which one is the per law? 5, right? So it's 5x plus 15. Right. on the test, you definitely need to know how to write these equations. You have to know how to come up with that. Yeah, so these ones are okay. Graphing it and then finding the intersection point. Okay, just like what we did in assignment number 3. This one, rearranging it into slope-intercept form. So y equals mx plus b form. And then, oh, this word right here. I don't know if we talked about this. What does the word collinear mean? Yep. Right. So if you have a line, do all 3 points, are all 3 points on the same line? How do I check that? Instead of graphing. I can't just graph it and say, looks like it goes through all 3 points. Yep. Right. So you have to check the slope between these 2 points and the slope between these 2 points. Right? I don't have to check the slope between these 2 points because if it's the same here and the same here, it means it's the same for all 3. It implies that. Okay. And then lastly, remember I said you do have to know this. Okay, so given 2 points, find the equation of the line. So slope formula, find y-intercept, and then the equation. Okay, so that's, I'm going to stop there. And then I'm going to, for the rest of the class and over the weekend, if you can finish up page 9 and 10. Okay, finish up 9 and 10 so that on Monday we can take up the rest of this. Answers are given right here if you are anxious to see if you got it correct. Okay.